Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face Trending List, published on July 29, 2025, just yesterday. This paper introduces a new dataset and a baseline model designed to help AIs segment objects based on their motion, not just their appearance. The paper is titled Move, Motion-Guided Few-Shot Video Object Segmentation, and as we'll see, their proposed model establishes a really strong new benchmark for this task. The authors argue that current methods struggle because they focus on static categories, ignoring rich dynamics in video. So the first figure really visualizes the core idea of motion-guided few-shot video object segmentation. That term just means teaching an AI to find and outline an object in a video, using only a few examples. Here, the examples, or support videos, show two distinct motions. One is Cristiano Ronaldo's celebration. The other is two cartoon mice hugging. The AI then watches the query video, a soccer match, and successfully segments the players who are performing those exact motions, ignoring everything else. This shows the shift from identifying what an object is to what it's doing. Building on that, the next figure shows a powerful, practical application. The model is given a support set showing a specific motion. In this case, the Joker's famous dance on the stairs. It then uses this motion as a query to search through a large video database. And look at the results. It finds completely different people in different settings performing that same distinct dance. This capability is really the core point. You can find novel actions that are almost impossible to describe accurately with just text or a single image. To enable that kind of motion-based search, you first need the right data. So this table compares their new dataset, Move, against other major datasets in this field. The key difference is right there in the label type and support type columns, while existing datasets like YouTube VIS label by object and use a single image as the example. Move labels by motion and uses a full video as the support. And this is a massive dataset with 224 motion categories, 4,300 videos, and over 300,000 high-quality segmentation masks, which are precise pixel-level outlines. So, to tackle the challenges presented by their new Move dataset, the authors propose a new model, and this diagram shows its core component, the decoupled motion appearance module. The key idea is to explicitly separate what an object is from how it's moving. It creates an appearance prototype by looking at the object's masked features. Then, for motion, it calculates the difference between frames and uses a 3D convolution, which processes video in height, width, and time to create a distinct motion prototype. This ensures the model learns both appearance and dynamics independently. So to really drive home why this new model and dataset are needed, the researchers present this necessity study. It compares several existing models on the standard YouTube VIS dataset versus their new Move dataset, and the results are stark. For instance, a model called CCAN, which is a few-shot segmentation method that uses an image as a guide, scores a solid 62.3% on YouTube VIS. But on Move, its performance plummets to 40.6%. This sharp drop across all tested models proves that current methods, built for object appearance, truly struggle to segment based on motion alone. Alright, moving to the main results. This table pits their new decoupled motion appearance network, or DMA, against those other methods on the Move benchmark. The key metric here is JNF, which is a combined score measuring how accurately the object is outlined. The results are really clear. Using a ResNet 50 backbone, which is the foundational part of the model that processes the visual data, their decoupled motion appearance network hits 50.1% JNF. That's a huge leap over the next best at 45.4%, showing their approach really works. So to wrap up, this work introduces a vital benchmark for segmenting objects by how they move, not just what they are. Their proposed decoupled motion appearance network provides a strong foundation for future research in this direction. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.